of the association, Dr. M. Madhu, our senior colleague, Sarma Sahab, Srivastava sir, Ramanjit, secretary, and all esteemed our colleague, and today's our speaker, Dr. Soma Sundaram ji. Today, of course, it is known to everyone, and soil said Mother Earth is among all most important and valuable. As we know, we heritage from our ancestors and our duty to preserve it and again hand over to our next generation. So, on behalf of Indian Association of Soil and Water Conservationists, of course, it gives me immense pleasure to welcome you all, sir, to this special occasion of World Soil Day. Every year, as we know, 5th December reminds us that soil is not just a medium for plant growth. It is a living system, a foundation of the life and food security and ecosystem balance. This year's theme emphasizes the urgent need to protect our soil resources from degradation, erosion, contamination, and misuse. All these terms are so common, popular, and also truly linked with the climate change impacts. Healthy soil ensures healthy food, healthy ecosystem, and untimely a healthy planet. Ultimately, a healthy planet, no doubt. As scientists, researchers, and stakeholders, it is our duty and collective responsibility to conserve this valuable natural resource for the generation to come. So, on these issues, of course, we are celebrating today, and we are fortunate we have one of the scientists from our organization, particularly our institute, Dr. J. Soma Sundaram ji. And I requested, our team requested, and he given consent to deliver a speech, particularly on talk today's day. So thanks, I am expressing my thanks to Soma Sundaram. And since already I have conveyed that we are busy in some work, official duties, so not taking much time, I am again expressing my welcome and warmness to everyone for attending this online and offline. Members from our association or other organizations also joined with this and requesting our president to say a few words on this occasion. नहीं आ रही है आवाज.
Okay. Yeah, sorry for that. Okay, thank you, Dr. Amrish ji, Vice President of the Association. And I profusely welcome you all to this wonderful discussion, particularly on World Soil Day. Yes, we know that the soil is a key resources, a living entity. It is the duty and responsibility of each and everyone to safeguard is health. Until unless soil health is improved, the living entity they will not become a good health. That means a one health concept. Both soil also should be healthy and living resources and living entity also should be healthy in terms of ecosystem services. We know that challenges presently what we are facing is the degradation problem and the biodiversity, losing of a resourceful biodiversity And the climate resilience aspect, much more important, is soil is providing the resilience, but actually that resilience capacity is decreasing. That's why the government of India also initiating a Bharat Soil Health, the program, and they wanted to have a dedicated the institution and monitoring institution at the national level, so that the soil health and other related aspect it will be taken care. We know that the many ministries they are dealing with the soil, but actually it is not unified. The unified the soil resources and mapping the government of India is planning. Let us hope that that it will come into effective uh, with the support of all the SAUs and ICR organization and other R&D organization, including the state agency and also the ministries. And also, I request our esteemed members to contribute at least some topic or publication related to the soil health, either in terms of carbon farming or carbon sequestration or ecosystem resources and soil and water conservation, how it will going to effective in enhancing these uh, the climate resilience aspect of the soil. I request you all to contribute. We have a watershed exclusively bulletin is there, and also we have Indian Journal of Soil Conservation, so that it will be communicated to the a larger uh, the stakeholders. Yeah, with this, I am not taking much of your valuable time. And the soil is a national resource and also it is a heritage. It is a duty of each and everyone to safeguard it for the future generation. Yeah, again, actually, I welcome Dr. J. Somsundaram. He is giving a speaker of today related to the carbon farming with the context of Indian situation. And our esteemed senior colleague, Dr. A.K. Srivasaji and Dr. R.K. Singh ji and other colleagues from the institute and also the members, honorable members and the executive member, vice presidents also, they have joined on this occasion. Uh, and I also thank Dr. Ramanjit, secretary of this association, for initiating this activity to have some deliberation on World Soil Day. Dhanyavad, thank you.
Thank you, sir.
So now, and before your talk, requesting Dr. Ramanjit, please share a brief biodata.
Okay, sir. Respected all. Uh, First of all, I would like to welcome on the behalf of our association for speaker, Dr. Soma Sundaram Jayaraman. So I want to tell his biodata in some brief that Dr. Soma Sundaram has started his career in our institute research center Kota, and then he was selected as a senior scientist in Indian Institute of Soil Science Bhopal. Then he again joined at present in the research center Uti as head of the center. So Dr. Somasundaram has very vast experience in the field of soil science in terms of carbon sequestration, green gas house emission, and ecosystem services. He has handled 24 research projects and he has also 24-year experience in research and training. And he has very important feather in his cap, that Endeavour Research Fellow in 2015. This is a very prestigious fellowship which was given by the Australian Embassy. And also he is the fellow of National Academy of Biological Sciences, Chennai, and he is also fellow for association, and he is also fellow of Indian Society of Soil Science. And he has also worked as a team leader to directive the Jabalpur High Court in a Omkareshwar command area. And he has also published some book for the NCRT for 11th and 12th class on soil and water testing analysis. And at present, he is working as an associate editor in Soil Research, which is a very prestigious journal of CSIRO Australia, and editor in Farming System Research also, Soil Intelligence Research, and associate editor in Soil Use and Management also, and co-editor in chief in our journal also. So he is serving and very actively for our association also. So thank you very much, sir. In the brief, this was the biodata. Sir, now I invite you for the topic is carbon farming, soil health, carbon sequestration, and ecosystem services. Sir, now form is yours.
Thank you, Dr. Ramanjit. Can I share my presentation?
Yes, sir. Yes, sir. You can share.
Is it visible?
Yes, sir. It is visible. Only put in that screen mode. Yes, sir. It is now visible. Clear, sir. Go ahead, please, sir.
At the outset, first I thank President and Director Dr. M. Madhu sir for giving this opportunity, and also thank Vice President Amrish Kumarji and Chief Editor Dr. Rajiv Singh and Secretary Dr. Ramanjit for giving this wonderful opportunity. And then my greetings and good wishes on the World Soil Day. And I will be presenting carbon farming, soil health, carbon sequestration, ecosystem services. I will be sharing my experience also. At the end, I'm open to have a discussion also after my presentation. So our director, Honorable Director, has rightly pointed out that soil is a living entity. Our Vice President also said, if you look into the worldwide scenario, the land degradation is one of the major issues similar to climate change. So more than 33% of the soils have been degraded worldwide, and India is not new to that. The Indian context also, the land degradation is very prevalent, and we are losing very valuable top fertile soil every year, along with that nutrient, essential nutrient into the river, lakes, and sea. So our institute is also mandated and looking after all those issues and addressing on developing solutions for that. So this is one of the important issue. And then out of 8 billion population, 3.2 billion people is being affected by the land degradation scenario. When you look into the climate change scenario, the carbon dioxide ppm elevation in the atmosphere is in a greater level. So last year it was around 424. This year it is around 427. Almost 2.5 ppm is increasing every year, and that is a real cause of concern. And agriculture plays a major role in second largest sector in terms of greenhouse gas emission. Why it is so? Because the historical carbon loss from the global cropping soils not only contributed to the increased GHG emission and also climate change. It's happening worldwide, and we need to devise a solution. We need to develop a sustainable soil management practices. Thereby, we can revert or we can reduce the carbon dioxide emission into the atmosphere. The moment you think of healthy soil, it performs many soil functions and services, namely primary productivity, water regulation and purification, carbon sequestration, provision of habitat, and then nutrient cycling and nutrient provision. So these are the functions is being done by these, and it's continuously providing, delivering these functions. And that's what, whenever we say healthy soil is required for the healthy life. And our Honorable Director also pointed out that nowadays One Health concept has been discussed worldwide. And then soil health equal to One Health concept. If you look into the data, the more than 2 billion people suffer due to different malnutrition or micronutrient deficiencies. And then soil degradation leads to this kind of issues. That's what the Food and Agriculture Organization always suggests for the healthy soil, for the healthy life. Because soil provides more than 95 to 98% of the food grain generated from the soil. That's what we need to have better soil for having a nutrition. That is what nowadays people used to say, that food and nutritional security. So that's what our management practices, either soil management practices or carbon farming, should address that nutrition aspect as well. Today we are celebrating World Soil Day, as you all aware, and it has been started way back 1 decade before. That is UN General Assembly, at the 68th General Assembly, they have denoted 2014, and 5th December is celebrated as a World Soil Day, and commemorating the birth anniversary of Thailand King Bhumibol, that Bhumibol Adulle Tej. His birthday has been commemorated as a World Soil Day, and across the world and across country, different thematic areas started from 2014. Soil is the foundation of family farming. Like that, 2015 is soil is solid ground for life. Like that, it started, and it created a mass awareness among the farming community, general public, and student community. And if you look at the other side, soil name neither mentioned in the SDG document, Sustainable Development document. However, it addresses more than 7 to 10 SDGs directly and indirectly, like SDG 2, Zero Hunger, SDG 3, Good Health and Well-being, SDG 6, Clean Water and Sanitization, SDG 11, SDG 13, SDG 15, Life on Land, like that. If you look into the outer cycle of that right-hand side figure, it helps in biomass production, pest and disease control, water quality and supply, erosion control, climate regulation, biodiversity conservation. And then our institute is also mandated and addressing the left side 3, that is erosion control, climate regulation, and biodiversity conservation, in order to address the soil and water conservation. So this is the importance of soil. That's what the Food and Agriculture, along with the Global Soil Partnership, GSP, worldwide celebrating on World Soil Day. This year is being celebrated as a healthy soil for healthy cities. That was the thematic area. And if you look into the sustainable soil management, 2/3 of world population expected to live in cities. That's what this year, the healthy soil for healthy cities. Urban soil provide essential ecosystem services. They support food production and water filtration, storage of carbon, regulating climate, particularly temperature and rainfall, and sustained biodiversity. That's what I want to highlight. Today's theme, the Food and Agriculture focusing on this aspect and celebrating World Soil Day. Whenever we talk about soil health, the next important factor comes into our mind, that soil carbon. Soil carbon plays a major role in maintaining a global carbon cycle. If you look into the pool of different carbon pools, that soil pool has 3 to 4 times higher than the atmospheric and biotic pool, biotic reserve, rather biotic carbon pool. And within that soil carbon pool, soil inorganic carbon consists of 950 petagram carbon. Inorganic, yes, soil organic carbon is 1550. Atmospheric carbon is around 760 to 860, and biotic carbon is 720 to 800. So this is the scenario, and we need to protect carbon in the soil. However, the moment you convert the forest land or pristine ecosystem, we are losing 10 to 50 or 60% of the original carbon. So we need to have a management system so as to revert back the carbon lost into the atmosphere. That's what the global meta-analysis also says, that the moment you convert the forest land or moment you convert the pasture land, the whatever carbon stored in the soil is lost into the atmosphere. That's what we are talking about today, the carbon farming. And then carbon farming is very much essential to restore the carbon lost from the to the atmosphere and bring back from the atmosphere to the soil system. And I would like to share some of the knowns and unknowns of carbon, because we are talking about the carbon farming. And then traditionally, researchers have believed that organic carbon primarily originated from plant detritus. But new research suggests that microbes may be the major source of organic carbon. It contributes nearly 50 to 80% of the carbon in the soil. So this is one thing. And another thing, tens of millions of species of bacteria, archaea, fungi, virus, and microeukaryotes coexist underground. And it's enormously contributed to the microbial biomass carbon also. One thing, whenever we discuss about soil organic carbon, we often forget that soil inorganic carbon. I was explaining that soil organic pool, soil carbon pools rather. So in that, 750 to 850 petagram carbon is denoted by the soil inorganic carbon. And it has received a greater attention worldwide because high accumulation of SiC rather than SOC it is documented in arid soil worldwide. And SiC storage in dryland soil is a complex process comprising multiple interaction of several factors such as climate, land use types, farm management practices, irrigation, and inherent soil properties. All these things plays a major role in sequestering or storage of soil inorganic carbon. So very less research has been done, and but the upcoming researcher, young scientists can think over it. And then most of the time we discuss about the SOC, but young researcher, I would suggest that they can think over of SiC improvement in the soil so that it can be stored as a recalcitrant form of carbon, and it can be long lasting forever. It cannot be lost by other management practices in an immediate effect. So the one more thing I would like to highlight here, that whenever we talk about carbon, when you intrinsic carbon into the system, soil system, automatically the microbial diversity will be very high, in a higher state. Thereby it helps to suppress the disease occurrence in the soil. That's what carbon farming definitely helps to improve the disease suppressiveness in the soil. That is, disease suppressiveness is the reduction in the incidence of soil-borne diseases in the presence of host plant pathogen in the inoculum in the soil. So this concept, we published a review in Journal of Soil Science and Plant Nutrition, and it got a global attention that within a year, 100 citation we got for this paper in Journal of Soil Science and Plant Nutrition. Because the moment you go for increasing carbon content in the soil, the microbial diversity, as I said, microbial diversity gets improved. Thereby, it gets a very good soil condition, I would say. So that's what we need to protect carbon. We need to protect carbon in the soil system. In order to address the soil health and carbon sequestration, 4 per 1000 program, that is 4 PT, and sustainable development SDGs, also sustainable development goals, biodiversity and NPP, net primary productivity, sustainable food production, it is also addressing food nutrition security, clean environment and ecosystem. So this we published in one of the leading journal, Frontier in Sustainable Food System. We run a research topic, and to your information, this research topic attracted worldwide 2.2 lakh views for the last 2 years. When you talk about protecting carbon or safeguarding carbon, there is always a 3 kind of process involved in that. One is physical protection, and biological protection, and chemical protection, among which chemical protection is also important, very important, due to the direct absorption of organic molecules and then enhancement of aggregation by the mineral. But it can able to protect the carbon for the longer term. So this is the way we'd like to adopt it. Coming to carbon farming, generally people used to ask that what everyone is telling about carbon farming, carbon smart farming like that. Any farming approach able to reduce greenhouse gas emission and increase the carbon sequestration in soil and vegetation is called carbon farming. And it also implement practices that enhance the carbon storage or carbon sequestration in agriculture ecosystem while promoting sustainable land management or sustainable soil management. If you're able to adopt the best management practices, we would be able to sequester or storage carbon 400 to 1200 kg per hectare per year. And somewhere carbon farming also synonymously used with the carbon smart farming, and the same principle and definition applicable here also. Any smart technology or management practice able to sequester carbon in our soil can be increased by adopting the right management practices. Right management practices or best management practices or good agriculture practices, BMP or GAP, good agriculture practices like conservation tillage involving reduced tillage, no tillage, and minimum soil disturbances, planting cover crops, and using organic addition, either enriched compost or biochar application, able to store more amount of carbon. The key practices in carbon farming, you all very well aware. Just I want to highlight that agroforestry, cover cropping, reduced tillage, no-till farming, composting and organic amendment addition, improved grazing, silver pressure, and the perennial grass. These are the prevalently spelled out key practices in carbon farming. Some of the portions I will be covering, not every aspect. Some of the portion I will be dealing in this presentation. So when you look into the agriculture practices, you can divide that agriculture practices in two terms. Any practice is able to increase the carbon sequestration potential that comes under the I category, and that is moves from the center point to the right hand side, like conservation tillage, improved grazing, cover cropping, biochar application, agroforest system. The carbon sequestration potential is high. When you move from center point to this side, residue burning, imbalance of nutrient application, and rice cultivation, all these things leads to less carbon sequestration potential. And then Professor Ratanlal sir estimated the carbon sequestration potential in India, and it is around 39 to 49 teragrams carbon per year. And if you bifurcate this sequestration potential, restoration of degraded lands, degraded soil rather, it's accounted for 7 to 10 teragram carbon per year. Erosion control, our institute mandate to address soil and water conservation, able to sequester or able to capture carbon 5 to 7 teragram carbon per year. And as I mentioned in my previous slide, that recommended management practices, RMP, BMPs, GAPs, and it's able to go for 6 to 7 teragram carbon per year. And secondary carbonate, I was highlighting the SIC, that soil inorganic carbon I was highlighting. It has an enormous potential in India to capture this kind of carbon. And looking to the left-hand side, whatever management practices or cropping system, if you go for it, and cropland able to sequester 500 to 1000 kg carbon per hectare per year. Similarly, grassland 550 to 500 kg carbon per hectare per year. And if you go for forest land adoption, 500 to 1000 kg per hectare per year. So this is the kind of situation exists, and where we are heading and how we adopt and how to sequester carbon. This is our question marks emanates whenever we take up any kind of research projects. And soil carbon is stabilized through deep placement interaction with the clays, as I mentioned, with the formation of stable aggregates, mineral complex, it can able to hold carbon for quite long time. So that's what adoption of recommended practices can be promoted for the payment of ecosystem services. And coming to the carbon farming and ecosystem services, it addresses provisioning service, regulating service, and supporting service, and as well as cultural services also. And one of our review, we have highlighted that how conservation agriculture address different ecosystem services. We have put here that it addresses biodiversity, air quality, water quality, and food and nutrition quality also. So this we published in Agriculture Journal, and then it also got a very highly referred article in our publication. So the conservation agriculture also delivered a lot of ecosystem services. And then another concept that no-till farming, which also improves the soil health, but also enhances carbon sequestration, crop productivity, mitigate GHG emission through appropriate crop residue and nutrient management. So this we ran one special issue in the Australian Journal of Soil Research, and then it also got lot of views for the last 3 years. So this is one of the very highly referred articles, and then the adage says that one size won't fit for all, because we cannot have same kind of one kind of recommendation can be applied everywhere and elsewhere, but we need to have a location specific approach so that we can capture more amount of carbon. As I mentioned in my previous slide, that conservation agriculture is able to sequester more amount of carbon, and not only carbon, it is able to save the energy, it improves this soil moisture storage in the profile, and also nitrogen content in the soil profile. And equally, people used to talk about regenerative agriculture also, conservation agriculture, no-till farming. These are all the component of carbon farming. They're able to store carbon in higher rate and also improve the soil health. Nowadays, regenerative agriculture also is alternate to the residue burning. Conservation agriculture is a part of regenerative agriculture, able to revert land degradation, maximize crop productivity per unit area, enhance carbon storage and soil health. As I said already, it is also delivering multiple ecosystem services. And then if you go for the conservation agriculture, no-till farming, definitely there is an improvement in the carbon, and then there is a protection of carbon within the aggregate. This is one of our study we published in the European Journal of Soil Science, and the less different fractions also we quantified under the no-till farming system. Less label and non-label fraction contribute more than 50% of TOC under our study. So this I want to share with you all. And then continuous adoption of no-till farming or conservation agriculture from 0 year to 8 year, 10 year, there is a conspicuous increase in the soil organic carbon in the black soil. And then we have also quantified carbon stocks also we have quantified. And then wherever you go for the better management practice like no tillage with residue retention or reduced tillage with residue retention, there is a clear-cut increase in carbon when compared to the farmers' practice, where they go for residue burning or removal of stubbles, removal of crop residue. So this we have documented, and then we wrote one review in critical reviews in plant sizes for the entire South Asia, and this attracted a worldwide attention that what is the exact condition is going on in South Asia, particularly Indian context. If you look into the worldwide scenario, the no-till farming or conservation agriculture area is 210 to 220 million hectares at the rate of 7 to 10 million hectares increasing every year. But in Indian conditions, still it's oscillate between 4 to 5 million hectares. So the adoption rate is very less, though the benefits are very enormous, but the adoption rate is very less due to one or other reason, non-availability of farm equipments, or farmers unable to manage the weeds in a proper condition. So that all results to non-adoption of CA practices. As I was mentioning, that continuous adoption of no-till farming and conservation agriculture able to sequester carbon, and if you go for adoption of these technologies for 40 to 50 years, there is a conspicuous increase in the carbon. But the stabilization takes depends upon the soil type and climatic condition. Say, for example, some of the global researchers, Weston Marland and Sauberg and Ingram, they suggested that at least the carbon stabilization or takes place 50 to 100 years. Some author they say that, somewhere they say that 20 to 40 years takes to reach the stabilization. But there is a buildup of carbon is there. In our own study says that every system lose the carbon, but the amount of loss of carbon is comparatively less when compared to the conventional kind of farming. So whenever you go for no-till farming with residue retention, with appropriate nutrient management, particularly nitrogen I am talking about, when you go for the nitrogen application, then there is a buildup of carbon. But keep in mind that if you go for more amount of nitrogen into the soil system, there is a clear increase of nitrous oxide emission into the atmosphere. That's what nitrogen is a key for improving carbon, and at the same time, you need to watch on the greenhouse gas emission. Keith Mawson is a Nobel laureate, also highlighted that nitrogen plays a major role in carbon sequestration, but at the same time, you need to keep a watch on that, how much you are applying, what is the dose you are applying. Say, for example, if wheat, you need to apply 120 kg of nitrogen, stick to that. Don't go for double, or some people, farmers, they go for 150, 200 like that. The moment you apply it, the nitrogen use efficiency 35 to 40 or not beyond 50%. So 50% of the nitrogen goes as a waste and either as a nitrogen leaching, or it release into the atmosphere as a nitrous oxide. So nitrous oxide gas is highly potent. So you all very well aware, though nitrogen management plays a bigger role in carbon sequestration. That's what Islam, it's one of the example from the Ohio State University. Adoption of no-till farming takes from 0 to 40 years, and the left side y-axis is the total amount of carbon or stock. So it is increasing with the time. There is another study that wherever you go for the appropriate management practice or best management practices, no-till with stubble retention, with an appropriate nitrogen application, there is a clear-cut improvement in both soil organic carbon stock and nitrogen stock. This is our own study at Hermitage experiment. It's one of the second longest experiment, no-till experiment. One is at Ohio State University, another at the Hermitage no-till experiment at Australia. So this is our own study. It clearly indicate that when you need to go for the right management practices to so as to have that carbon improvement. And then when you talk about the carbon improvement, we also had one study at Western Ghats, that circular farming model in the temperate Western Ghats. The study result indicated that replacing FIM with mushroom spent substrate, increasing soil carbon storage, and also reducing the carbon dioxide emission into the atmosphere. This is our own research center study indicating that application of mushroom spent substrate or either enriched compost with phosphorus, improving the carbon storage and also emitting less carbon emission into the atmosphere. So this combined approach not only provide a practical way to offset carbon emission, but also highlight the potential for farmers to earn revenue through mushroom farming. So this is one study. The other study conducted in our research station at Koraput, and how soil management through watershed development and on ecosystem services in Eastern Ghats, they also quantified that how provisioning service, other than the provisioning service, taking into other services into account, how it is helping farmers. And Suresh Kumar and co-workers estimated value of economic incentive to watershed farmers for conserving the natural resources. Because when you implement soil and water conservation, measures, because watershed in a holistic manner, they can able to earn $249 per hectare, and that which is equated to 20,000, 21,000 approximately as of today. So well-managed watershed supports human well-being, not only human well-being, but also indirect benefits, including regulatory, cultural, and supporting service. This is another study. And then our institute also developed some of the policy framework also. So the water erosion is a prevalent. Our institute is addressing all those issues, and then we how different soils through water erosion, how much productivity loss is there. Quantified like alluvial soil, it's around 3.5 to 60%. Black soil 10 to 40%, and red soil it is around 5.5 to 10% like that. Dr. Dogra and our director Madhu sir, they quantified that how erosion impacting on the food security. Similarly, another study done by Vanita and co-worker, that they assessed that how watershed management impacts the livelihood of farming community under different agroecological regions and across length and breadth of the country. More than 10 different watersheds they have taken, and then they assessed, and then these are all implications that how soil and water conservation impacting on the livelihood. Different management practices have been suggested to improve the soil health and soil productivity, like I&M, biological nitrogen fixation, use of biofertilizer, conservation agriculture, use of contour edge crops, engineering structure, incorporation of cover crop, mulching, and residue incorporation, application of manage everything. It's all everything. People used to say that, okay, it is improving. Then the next question comes in our mind, okay, all these management practices improving soil health and everything. So how to quantify it? Whether farmers are able to understand what we are saying, and they are able to understand how much fertilizer they can able to apply, or which time interval they go for soil testing. There is always a knowledge gap, and this has to be addressed. And when soil health card intervention done by the government of India during 2014, since then there is a greater awareness on soil health card distribution, soil health card generation rather. So addressing only chemical component of parameters, nitrogen, phosphorus, potassium, and chemical parameters, micronutrient, organic carbon. But sometimes we are forgetting about inclusion of physical parameters, biological parameters. Now recently, Bharat Soil Health Policy is coming out with the inclusion of 16 parameters of as a comprehensive soil health assessment. So they are coming out with one policy draft. Recently, our director sir has shared the document with us. So they are coming out with a comprehensive soil health assessment involving physical, chemical, and biological parameters also. So another thing is that whenever we talk about soil health assessment under different scenario, either carbon farming or natural farming or organic farming, what should be the framework? We need to be clear in our objective, and what should be the indicator, what are the indicators, and if you go for the best management practices, how best it is giving the best benefits, like cost benefit ratios or cost effective. Smart indicators also we need to include, systematic sampling, designing, and we have to involve multi-stakeholder engagement and awareness, that is a capacity building, and adaptive management and data management analysis. Interpretation, though we have a very good data analysis and everything, very sophisticated laboratory, but understanding the information, particularly the indicators and the interpretation, that is more important to advocate farmers. So these are the things I want to share with your elite audience. So in addition, we need to combine the latest technologies also, like drone, remote sensing, and systematic field sampling using LDS and citizen science. All these combination we can able to address the land degradation as well as restoration progress in the real time manner. And then we always talk about healthy soil, healthy life, soil health for the arable crop. Now the today's we were discussing about healthy soil for healthy city. Now the concept clearly mentioned by Sun et al. 2023 that the urban ecosystem also play a major role for the soil health as well as ecosystem services. This picture vividly indicate that how different component like green wall, green roof, indoor plant system, urban park, and urban farming, all these things helps in sustaining biodiversity, weather regulation, that is temperature, rainfall regulation, climate regulation, rather, I would say. So all these things play a major role. So we need to think of nowadays green building or a energy efficient building also they construct, keeping glass or like roof gardening, and so on. So these are all very important. So I want to throw some highlight on this aspect as well. As I already mentioned that significance of carbon farming, and it improves soil health, carbon sequestration storage is there, and biodiversity development enrichment is also there. So if you put into the benefits, direct benefits of carbon farming, we have recently published in Advances in Agronomy that carbon sequestration, soil health, yield improvement is there, improvement in soil moisture storage in the profile, less GHG emission, water retention, as I mentioned, climate regulation or mitigation, improvement in soil structure, nutrient cycling, all is the direct benefits of carbon farming. And then indirect benefits, all these things come into picture, that biodiversity conservation, improved air and water quality, resilience of extreme weather, enhanced food security, and so forth. These are all information I want to share with you. These are the indirect benefits of carbon farming. The next question comes that what are the global farming initiatives, global carbon farming initiatives, like 4 per 1,000 program initiatives I already mentioned. Kenya's Agriculture Carbon Project, World Bank funded, was introduced in 2015 in the United Nations Climate Change Conference. That is also attracted worldwide. And one more important, Australian Carbon Farming Initiative, advocate carbon farming on global scale. And one more thing, European Union Sustainable Carbon Cycle Initiative, that is a European Green Deal, is also funding. We can also try for getting funding from this project for carbon related project. The initiatives such as Horizon Europe also highlight that how soil health is important. And similarly, PLACA, that is a platform on climate action in Americas, adopting African agriculture, AAA. These are all the global efforts addressing the soil health, so carbon storage or carbon sequestration versus carbon farming. And then emission scenario also, emission trading system. And now the government of India also coming forward and developing some framework for assessing the carbon credit also. This is the schematic representation that implementing carbon farming, the right hand side, if you move, then it improves the soil health, carbon storage, as I mentioned in my previous slide also, supports the climate action. If for which you need a financial incentives to support this kind of project. Carbon credits with the soil, a bridge gap between climate mitigation and agriculture. There is always a saying that simple action lead to a big result. And we often forget the cover crop inclusion. Previously, when we were doing UG, PG, that time cover crop inclusion is one of the component in agriculture. Now, people are in the want of higher income or high output. The people are not going for inclusion of cover crop, but it is estimated that if you go for 20 million acres of cover crop, which can able to sequester 66 million tons of carbon dioxide equivalent in a year, which is equal to emission of about 30 million vehicle emission. So see that. So that's what we always need to go for, some of the simplest thing which can able to bring a a greater change in our farming system. So carbon credits a link between sustainable farming and climate mitigation. This carbon farming provides opportunity for participation in the global carbon markets and offset programs, and offering a promising avenue for revenue generation. So some of the examples I have given here, the government initiatives like carbon farming, such as European Union Common Agriculture Policy (CAP) and the USDA NRCS program. These are initiatives are distinct from carbon offset market. So CAP and NRCS program focusing on promoting sustainable practices through direct support, whereas carbon offset markets could enable farmers to generate revenue by selling carbon credits. I'll talk about more on carbon credits in upcoming slides. Then we can have a discussion at the end of my presentation. So as I was mentioning that if you go for the right management practices or best management practices, able to sequester 400 to 1200 kg carbon per hectare per year. Carbon markets allow to store carbon, and it can also be traded as a carbon credit. That is a carbon credit certificate, CEC. So, and also it can reduce the emission. This is what when I was reviewing some of the information, there are different tires are being used to give the credit. Say for example, lower end credit address 700 rupees only per tons of carbon dioxide equivalent emission. If you revert back, then you will get only 700. If mid-tier evaluation, it leads to 1700. If high-end estimation, that is ETS, then it is going to give you 4,700 to 6,400 rupees. My point of discussion in everywhere I present, farmers should at least get 1 rupees for 1 kg of crop residue. Forget about the carbon dioxide equivalent storage. Farmers should get 1 rupees. This is my the suggestion wherever I make a presentation, and this is my suggestion. 1 rupee at least they should get for 1 kg crop residue retention into the field. Then if a farmer retain crop residue up to 2 ton or 3 ton, at least they should get 3,000 rupees. Minimum estimation, lower end estimation. So this is what I want to share. So you all aware that carbon crediting system, that CCTS, carbon credit trading system, Indian carbon market. The question next comes that what is a carbon credit? Carbon credit is the unit tradable permit that allows a holder to emit 1 ton of carbon dioxide equivalent. That is 1 carbon credit. If you're able to store that much, then you will get a 1 carbon credit. It aims to create an Indian carbon market to facilitate trading of carbon credit certificate. That's what I was mentioning, CCC. So each representing 1 ton carbon dioxide equivalent reduction, you will get 1 carbon credit. There is always a debate goes on that carbon credit trading scheme. Two type of mechanism followed. One is compliance mechanism, another one is offset mechanism. And then if you look into the voluntary carbon market system, Ministry of Agriculture and Farmers Welfare has developed a framework for promoting VCM, voluntary carbon marketing system in India for agriculture sector. Already Ministry of Energy, they have already formulated for 8 different sectors. Now our ministry also developing, introducing carbon market to the farmers, can accelerate the acceptance of eco-friendly agriculture practices that can be tradable. So the major objective of VCM framework is to create awareness and capacity building of stakeholders and motivating farmers to adopt sustainable agriculture practice. Thereby, they should get the carbon credit. And then the next point comes that how carbon credit works. First, the emission reduction and removal. And whatever project, if you take up, then either you should reduce the emission or you're extracting, or you can remove the carbon dioxide capturing into the system. Then for that, you need to go for this first step. Then you need to go for verification. Third party verifier ensure that emission reduction is real, measurable, and additional. And this one, uh, second step. Third step, issue of certificate, as I was mentioning previous one, and sale or trade. These credit can be sold on voluntary or compliance carbon markets. And some of the example I'm just sharing in Tamil Nadu, in Ottanjatram village, tree planted in high density model on fallow lands was linked to a carbon trading that income generated going to the village fund. This was initiated by Karur Vaisya Bank. Similarly, northern side, Haryana and Punjab in 2025, Varaha issued a US dollar 30 billion from sustainable asset invested to expand soil carbon program, benefiting 337,000 smallholder farmers across 6.7 lakh hectares. So these are the some of the example I put here that Louis Defres company funds major regenerative agriculture project in India. Similarly, Groundwork BioAgri are any climate partner to commercialize 5,000 tons of durable soil carbon credit. These are the some of the example how we can go for carbon farming and carbon how to get the carbon credit. And then okay, these are all okay, all goody things you are telling. What are the disadvantages of adopting the carbon? I have put in the left side, like disadvantages such as labile carbon storage at initial stage, measurement challenges, initial cost investment, yield variability, policy and market uncertainty, land use conflicts, target conflicts, long-term commitment. All this is disadvantage. Though I talked about most of the things, I talked about the advantages part. So what are the other aspect, other side of the this recently we published in this advanced in agronomy. So benefits of carbon farming already I discussed in my previous slide. So I'm skipping this slide. And then carbon farming system provide provisioning service like food, fiber, fuel, timber, fodder, raw material, medicinal usage, everything. And then coming to the next one, it also provides a regulating system and focusing on support biodiversity and ecosystem, and then improved pollinator and health and services, water cycle, increased crop yields and productivity, soil erosion control, and then enhanced nutrient cycling and availability, improved soil structure and fertility, and so forth and so on. These are the things, and then and carbon farming system provides supporting ecosystem services like genetic diversity maintenance, seed dispersal, many things. I have measured just to have a glimpse so that you can understand. I don't want to read line by line. So another thing that it's not only provide provisioning other services, it also provides cultural ecosystem services, aesthetic value, agrotourism, and many things. Okay, this is all carbon farming provides the ecosystem services. And one thing you have to always discuss about the other side. When you talk about the positive sides, you need to discuss about the negative side as well. What are the ecosystem disservices carbon farming delivers? Like it impacts socio-economic, cultural impacts, and then it impacts on economic and productivity challenges, land uses, resource competition, environmental degradation. All these things we put in a single slide. That what are the disservices? Say for example, adoption of carbon farming disturbs the land use pattern. Sometimes increased GHG emission, altering the land use pattern also, and nutrient runoff and leaching due to excess input, habitat loss due to conversion of natural landscape to agricultural land use. I was mentioning that change in land use leads to this kind of disservices, reduced air quality due to dust emission from tillage and machinery, agrochemical pollution and pesticide poisoning, and like that. In every aspect, it is given that what are the disservices that carbon farming is to deliver. And coming to my final stage of presentation, what are the future needs advancing carbon farming? One has to have the MRV, measurement, report and verification, and then you need to understand the microbial diversity, biodiversity, optimizing agriculture practices for more amount of carbon, and addition of amendments, particularly biochar, residue, and then enriched compost and manures. And then we need to integrate the model like carbon credit system models, economic models with this system. Thereby, you can understand that whether this system is cost effective or really benefiting system into the agriculture farming. So we need to assess, and then you need to also assess that climate resilience, ensuring the co-benefits for the farmers. Okay, we are adopting carbon farming. What should be the climate resilient? What are the other benefits? So the next one comes to the policy governance. It should be the top to bottom approach, and then farmers should be encouraged by the by properly incentivizing them so that they can go for this kind of adoption of this kind of management practices or carbon farming. So to recap my whole presentation, carbon farming plays a significant role in soil health, carbon sequestration, and ecosystem services. And then regarding carbon credit, still I feel that it is less for 1 ton of carbon credit what farmers or other industry people are getting. So in direct deals with the corporates or NGO, they may receive up to 2,000 rupees per credit. Like Varaha, I said, Grow Indica, Bhumitra, these are some of the organization. They voluntarily take farmers on the board to incentivize them for going for this carbon credit. Industry estimates suggest that initial domestic credit prices may start around $10 per ton of carbon dioxide emission equivalent, which converts roughly around 850 rupees per credit. So that's what I always say, that if you go for a earning potential of carbon credit, if a farmer able to sequester or able to store 1 to 4 credits per acre, they could earn up to 780 to 3,120 rupees per hectare, per acre rather. And at 2,000 per credit direct deals, then they may get 2,000 to 8,000 per acre. This is overview I am giving. So Ministry of Agriculture and Farmers Welfare released a voluntary carbon market framework to simplify the small to medium farmers. So states like Uttar Pradesh, Tamil Nadu launched agroforestry models, carbon project models. They are also generating huge amount of revenue in terms of carbon trading. So this is the overall my presentation recap. And finally, I would like to say that Food and Agriculture Organizations says that if a business as usual approach, if we go for, then only 60 years of farming is left out. So that's my interaction with you all, that increased investment in the implementation, monitoring, and policy and financing of carbon farming and soil health are very much essential. To conclude my presentation, location-specific carbon farming practices is need of the hour in order to address soil health, carbon sequestration, ecosystem services, and to develop SOC-based policies or soil organic matter-based policies. Now, Bharat Soil Health Policy (BHSP) in pipeline, and they are now, as I said in my previous slide discussion also, now they are taking a comprehensive soil health assessment and a program for sustaining soil quality, climate regulation, promote biodiversity conservation in line with UNFCCC or SDG programs, and focus on convergence of multi-ministerial programs such as NAPCCC, like National Action Plan on Climate Change or State Action Plan on Climate Change, SAPCC, and 8th national missions like NMSA, National Horticulture Mission, many things. So promote a farmer and community-centric, holistic, sustainable land management or sustainable soil management practices. Institutionalize payment for ecosystem services. The PES, the payment for ecosystem services to the farmers for adopting carbon farming and SOC enhancement in the practices. So And finally, I would like to thank our Honorable Director and President of EASWC, Indian Association of Soil and Water Conservation Society, and Dr. Amrish Kumar, Vice President, Dr. Rajiv Singh, Chief Editor, IASWC Dehradun, and Dr. Ramanjit Singh, Secretary, and all esteemed members and many senior members are there, Dr. Srivastava sir, Dr. Sharma ji, and Dr. Kanda and all other online divisional heads and regional section head. I would like to thank and sharing my experience for the last 20 years. I have been working with this kind of aspect. So these are my publication books I worked on this aspect. So thank you for giving this wonderful opportunity to share my experience I had with you, had in my research. Thank you. Over to you, Dr. Ramanjit.
Okay, sir. Yes, sir. So first of all, a very big thank you, sir, for delivering a very informative speech to us, and you educated us in all the aspects of soil science. Especially, you touched that new Bharat soil policy and especially ecosystem services and the other aspects of also that ecosystem services. And you know that any informative talk is incomplete without question and answer. So we can take some questions from our students also and some our regular the trainees also. They are also attending, sir, in a class. They are 22 in a number. So first we can start from students and then trainees and then our senior colleagues or colleagues. So it should be very informative, sir. So questions are welcome now. Likewise, in chat, if I can read some question. One question is that, dear sir, how soil is affected by dumping of solid waste management in long-term period and how it affects the evapotranspiration?
Solid waste management.
Yes, sir. In chat, one.
Yeah.
Yes, sir.
See,
Chat
actually,
box.
whenever anything, if you excessively apply, there is a clogging of macro and micro pores. Then there is a circulation of air will be affected and water transmission will be affected. So you cannot dump whatever you like. You need to keep a rational on that how much you are putting in that and how to manage that solid waste. Not that all very good arable land you go and dump the solid waste. There should be kind of a decision we need to take that the solid waste management consists of heavy metal also. And when you dump the solid sewage sludge into the arable crop, the crop may uptake excess some accumulation of heavy metal into the system, and you consume it, then it affects your health also. So you need to you will be cautious in applying that this kind of solid waste or sewage sludge.
Okay, sir. Yes, sir. So I cannot see that too many questions in the chat box. So now the forum is open. Anybody can discuss the things and ask the question. First, we will give the one question. No, sir. They are all giving you congratulations, sir. Thank you very much, sir. One question from Dr. Kannan. He's saying that it is high time to develop some MRV platform for soil conservation. So what is, sir, MRV platform? Can you tell?
Pardon? MRV.
MRV platform. Dr. Kannan is asking this question, sir. Dr. Kannan, please.
Right now, the monitoring report and verifying platform is developed only for rice, net to for alternate wet and dry method. The use sensors so that it will give alert and real time they can quantify. Right now we don't have any platform for our soil conservation soil and conservation program. We are developing a platform for Surcan trust-based biochar. Like that, we can also think of MRV platform for soil and water conservation platform.
Yes, sir. Yes, sir. Exactly, sir. You have rightly pointed out that definitely we should have soil and water conservation, watershed management, MRV, that measurement, reporting and verification, MRV. While I was searching that carbon credit also, sir, we are finding it very difficult that exact quantity. I find from NAS also, I took some information, carbon credit like that, MRV also. need to quantify. This is another area we can develop, sir.
Yeah, in that context, okay, Dr. Kannan, welcome. Yeah, Namaskar, Dr. Kannan ji.
Namaskar, sir. Namaskar, sir.
Yeah, with respect to MRV, just I wanted to say in the sense, even the analytical part, the monitoring and reporting and verification to take, but monitoring part and under the monitoring analytical part of soil is very crucial in the sense if you get analyze the same sample in the different laboratories and other things, the values are different. That need to be how I don't know as a soil scientist how you going to address that issue.
Yes, sir. Sir, that's what, sir. Actually, that analysis part is very important. We need to have a referral also. Whenever they are analyzing somewhere, that report has to be, or that sample has to be analyzed in the referral lab also to have a cross check. Then only we could find out. Like similarly, carbon credit evaluation, third party evaluation is there. In MRE, we should have that kind of approach, sir. So some laboratory they used to analyze, and then that sample has to referral lab we have to analyze to understand that whether we have quantified or reporting the exact what it is reported in the previous report. Cross check or cross verification like that. I didn't find this many information, sir, in this aspect.
Sharma sir, namaskar, namaste. Yeah, over to Ramanji.
Okay, sir. Sir, one question in the chat box that land degradation vis-a-vis soil carbon credit and soil health. What is your take on this for future work? I think you have addressed in this your presentation, sir.
Yeah.
Second question, second question is that the theme for this soil day is healthy soil for the healthy cities. So, what are the parameters related to the sustainability and city planning?
Yes. See, actually, the one of the concept that healthy soil for healthy city, sealing of soil in most of the cities, like in malls and other kind of infrastructure. Now they are throwing some point that we should not seal the soil. We should go for avenue plantation, tree plantation, thereby growth of lateral roots able to improve the infiltration of rainwater. That's what we need to, because that was sealing. Soil sealing is one of the key area addressed by the FAO. We should not seal entire soil. There should be kind of opening in terms of tree plantation, avenue plantation. Thereby, it improves the water infiltration, drainage system, and everything will be proper. That's what they are highlighting. And then green building also, I said no, green energy building, sir.
That's fine, but actually the linking is that particularly for the cities as such actually they will not going to produce any food.
Yes,
They
sir.
have
Yes,
to
sir.
get everything from the outside.
Rural
Until
side.
unless the soil quality in the outer environment where actually it is being produced, it should be the good quality so that actually the cities and other things it will be health will be improved
Okay,
because
correcting. Yes, sir.
and the living the lifestyle of cities are entirely different from the rural background. They need much more, yeah, healthier. The agriculture produce it is not contaminated due to the chemicals and other things, so that the health can be improved.
Yes, sir.
That is the main aspect of that.
Thank you, sir. Thank you for adding some more
Thanks.
valuable information, sir. Thank you very much.
Sir, one question is from regular trainees. They are asking that if a farmer want to start, he want to get carbon credit. So from where he has to start? What should be the steps?
That's what I mentioned. No, first we need to either we link with the NGOs or some kind of organization is there. We have to register with them, then only you will able to get that. Otherwise, they may not consider for carbon credit, either through NGO or through some organization. Varaha, Bhumitra, and other kind of thing are there in India. So you need to register with them, or you need to link with them.
But
Now
in
that
the
Ministry of Agriculture is coming up with the policy framework also to have carbon credit. I was mentioning in one of my slides.
Yes, sir.
but
Yes.
some private agencies are there for carbon estimations and sequestration estimation and other thing. But that is too costly, particularly for the small and marginal farmer, that they cannot able to do it. In that contestation, I have an idea in the sense each state at least they have either state level or the district level. The government should take the initiative from the base point to the either 5 years or 10 years or over the period in the time scale. They should regularly assess the green belt, either NDVA value or whatever the some of the indicator they have to use it, and through that the state they can invest the money for the carbon the sequestration evaluation, and whatever the money they will get it, the mechanism should be built out to share the money to the stakeholders.
I have one point.
Yeah, that's it. That's it.
Uh, at the outset, I congratulate and thank you for such a elaborate presentation about the the whole aspects of carbon management. Two things it comes to my mind. One thing is that the scale. I mean, it has to be. You did mention about the watershed scale, and that is where the different land use becomes very important, and the
Yes,
scope.
sir.
Considering that, for example, I mean, even in Nilgiris, Gudlur area, and all those areas, all the silvipasture area particularly, the scope is very high for that. On the contrary, the shallow soil, it limits the possibilities.
Exactly, sir.
Another thing that I wanted to highlight is that a balance and a long-term aspect. The studies have to proceed. I mean, that is what even the directors have, and you have also mentioned that right from the
Yes,
beginning it has to be assessed. And
yes, sir.
effective mechanism, effective mechanism for the credit sharing and credit advantages have to be there. We are listening for carbon credit for a long time. Thank you
Yes.
very much. Again, I congratulate
Thank you,
and
sir.
your excellent publications everywhere in the world. Thank you.
Thank you, sir.
One point, particularly for carbon sequestration or stocking, the soil moisture in a profile. There is any relation between the sequestration rate with the moisture? If moisture is higher, in which case whether sequestration is higher, or in case of low, it is low. Such a study or some standard methodology is available by which we can work in our experiments.
I'll share one of my paper also, sir, with you. But very rightly you have made, sir, regarding soil moisture and your vis-a-vis your carbon storage you are asking, no, sir? Am I right?
Yeah, yeah.
So you are asking about soil moisture storage versus the soil carbon.
Yeah.
Sir, in other way around, I'll put wherever there is a buildup of carbon is there and high amount of soil moisture storage is there. I'll share that paper with you, sir, through email. We have quantified up to 1 meter profile how soil water is stored under different management practices and how carbon is varying under those treatment. So
No.
you asked a very pertinent question that more amount of moisture storage is there where more amount of carbon is stored.
Yeah.
In other way around also, sir.
Okay, thank you. So any more? Dr.
Yes, sir.
Ramanjit Singh.
Yes, sir. I also want to ask some questions, sir. Sir, generally we agriculture scientists talk about the organic carbon, but we generally neglect this inorganic carbon. So how this inorganic carbon can come to our agriculture system and it can be used? This is my first question, sir.
Okay. No, generally, that's what I presenting that both SOC and SIC also. And SIC also equally important because it has more than 750 to 850 petagram carbon. And more focus should be there, like ca- precipitate carbon is there, no, like calcium carbonate. So we neglect those things, but that is also a kind of carbon able to sustain the soil health. So more, that's what I highlighted, that this area, youngster and young researcher has to take up and work on these aspect, like SIC. We only talk about soil carbon is SOC plus SIC. That is a total carbon. So we only talk about the SOC. We often forget or neglect SIC. So we need to give more emphasis for the SIC also. In the deeper layer, there is a deposition or precipitation of calcium carbonate in the form of recalcitrant carbon. So we need to give more attention on that. This is what I highlighted in my presentation also.
Okay, sir. And my second question is related to that simulation study, sir. We Indian scientists generally are not using that much of simulation tools, but in foreign
Yeah.
country, as you were also in Australia, they were using too much tools and they're expecting some kind of changes in the soil in context of climate change. So why we are not able to do that much of simulation studies?
The simulation study is always able to project your work. Say, for example, you are doing 10 years of study and you want to project to up to 50 years, 60 years, like Rothamsted, you can project. Already Rothamsted has crossed more than 150 years. They have 0 day from 150 years date. But we have that kind of data set may not be available. Say, for example, erosion versus productivity experiment itself. We don't have initial sample carbon or other aspect missing. So we could not run. Dr. Bijlal Lakaria sir is there. He is facing a lot of problem in simulating that model because some of the data are missing with us and we could not use that model effectively. As per my opinion, I may be wrong also. But we are missing some of the golden parameter at the when start of the experiment, and after 10 years down the lane, we think that this has to be done. So revisiting back to that original state, it's really a difficult one. By the time many manpower change, many scientific staff change, and all these things come into play. But a long term, as it has to be really a long term. One good example I'll tell you. I worked with Professor Ram Dalal. He worked with Mayer, Dr. Mayer, who started that second longest running experiment. Okay, but for the last 5 decades, more than 50 years, he is working. He is getting money through different project to run that project. There is an enormous burden on him that hand over that 2 hectare land to the Australian government. But he is getting a lot of fund from other agencies to run that project. Now it is more than 56-year-old. After Ohio State University is the second longest running. Similar kind of experiment we are lacking. That's what we could not use that modeling study to projection. What is the scenario in order to convince policymaker? We don't have that kind of data set. And then strengthening करके हम लोग को बताने के लिए ना हमारा पास कुछ ये नहीं है लॉन्ग टर्म प्रोजेक्ट है ऊटी में भी 15 साल लॉन्ग टर्म ईपीआर प्रोजेक्ट इज देयर some of the main data original initial data we don't have in bench terracing also we don't have, so we could not able to project our data in future vis-a-vis future scenario. We are facing problem. ये हम लोग को दिक्कत हो रहा है.
Yes, sir. I think Dr. Dinesh Jingar want to ask one question.
Yes, sir. Sir, congratulations, sir, for your wonderful presentation. I have
Thank you.
one question. What Dr. Amrish Kumar asked, you told that the higher moisture, then there will be the higher carbon, right, sir?
मैंने ऐसे बोला हायर कार्बन रहने में ज्यादा मॉइस्चर आ जाता
Then
है.
one of your article I have read, sir, that was published in Agriculture, that soil inorganic carbon as a potential sink in as a carbon storage in the dry lands. So
Yeah, I presented here also.
so I think it is reverse. I think you were telling, sir.
No, see that soil, that was a soil organic carbon. This is soil inorganic carbon, wherein transpiration, evaporation is much higher. Under the arid condition, there may be a precipitation of carbonate in the form of calcium carbonate or calcium magnesium carbonate. That's what is soil inorganic carbon I was mentioning. Dr.
Okay.
Ramanjit also asked the same question. So that article deals about soil inorganic carbon, SiC.
Okay, thank you, sir. Thank you.
Thank you.
Any question from other side? Our senior colleague, Dr. Brijlal Lakaria.
Congratulations, Dr. Soma Sundaram ji, for your elaborate
Sir, thank you, sir.
presentation, in-depth presentation on carbon farming. Very excellent presentation you have made. I just want to add supplement to your information as is being discussed about the effect of moisture on the carbon storage. Friends, just we can simply visualize wherever there is rainfall, high rainfall area, there is high content of carbon. Wherever you can see, right from northeast to North India, and when we move towards the eastern western part, automatically the carbon concentration goes on decreasing. The carbon content goes on decreasing. So there is a direct bearing of the moisture on the carbon retention. That is number one point. But overall, when we talk, the carbon retention in soil is a function of three parameters more. Another one is soil type. What is the amount of clay present? What is the amount of silt present in it? And the rainfall. What is the amount of rainfall? That decides how much carbon a soil can hold. And with regard to the point raised about the inorganic carbon, friends, we are working basically for the plant growth. We are working for the crop and soil health improvement. Both are in our mind. So even if we can increase the inorganic carbon in the soil, but that may also pose some problem. Inorganic carbon is that synthesis of the inorganic carbon it's a pedogenic process, and it takes its own time. So we are not going to hasten it. We cannot hasten it. Whatever is the soil condition, according to that is formed in particular area. You can take example of the western part. You can take out example of the central India. But our main emphasis, as emphasized by the speaker, that how we can improve the carbon, different practices wherever possible. So all those were discussed. Thank you so much.
Any more questions? Or anything you want to tell that how we can improve in the future regarding all these type of lectures and celebrations, webinars?
मुझे पूछ रहे हैं?
No, this
Yes, sir,
is
you can
common.
also tell.
common.
Sir, director, sir, president, sir को पूछिए.
Means this is one of the activity series of talk already going through the on the platform of this association. If any other activity, so that we can make a larger network in the country with the members, and also we can attract the persons who can enroll in our association. This is also our objective. So in that direction, if any suggestions, so most welcome.
I can see it, Dr. N.K. Sharma, sir. Sir, you want to bless us in some words?
Okay, thank you very much, Ramanjit ji. And namaskar, sabko namaskar. Congratulations, Soma Sundaram. Very good presentation. And I think it is all elaborative data which you have given here. Now, when we say about the soil day, FAO has tried to actually sensitize the people who are living in the cities. They purchase the food and eat. That's all. They don't know how it is produced and how it is actually generated, I will say, generated from the soil, it is a farmer's bank balance. Soil is a farmer's bank balance. If it is good, then it is good for others also. So I think the carbon is the centroid for the soil health. And the most important indicator, which I feel, that is the microorganisms. Okay, you can immediately, if the soil is not healthy, the first effect will go to the microorganisms. They will reduce, they will vanish, they will go away. Anything it can happen, but that is very important things. I think some physical chemicals, we should also give emphasis on the biological properties also. Okay, because this is a very important, it is a actually tool, or it is the instrument which make the soil healthy. And I think it is a very good initiative, as Dr. Ramanjit was saying. I think it should continue. Somehow we can discuss the very important issues. Sometimes it's come. Now, some new terminology, people like us, which are retired people, they know the new terminologies, new things which is going on in our countries, in our scientific forums and the environments. Thank you very much. This much I want to say. And the soil, actually, we should give emphasis on the soil to improve it as possible as. Now, the nano urea is also coming nowadays. It is not going directly to the soil, but it is going to the crop only. Okay, and the pollution is reducing out of that, because the more nutrients which are leaching, they are polluting water also. It is coming again at the top of the soil by the irrigations or drinking by the people. So that some these type of efforts, I think, should carry, so that the pollution of to the soil should be reduced. Thank you very much. This much I want to, because the time is very short. In nutshell, I want to say that soil should be saved, it should be healthy, and it should give a all functional, what is the responsibility of the soils. Thank you very much.
Thank you, sir.
Thank you, sir.
I
Thank you. Thank you
I
for
have a
your
suggestion.
So we are at the end. I think if there is no any further query questions, so of course it was a nice discussion here, and healthy soils and healthy city, theme of this year World Soil Day, and elaborate discussion. I think most of the parts we well discussed here, and it is highly informative for us who are actually not aware so much about the carbon farming. Word is very catchy, and everywhere we are listening. But what is the nitty-gritty in carbon farming? Of course, it is still a researchable issue. So with this, I am requesting Dr. Ramanjit to express vote of thanks. That is the end one. Or if Director Sir is
Yes, sir.
here,
Yes.
so we can ask for concluding.
Okay, Dhanyavad. Thank you, Dr. Amreshji. I must thank Dr. Somasundaram for his excellent presentation and
Thank you, sir.
elaborated discussion. I thank Dr. Ramanjit, organizing secretary, and also the society secretary, and our senior colleague, Dr. Srivatsa Saab, Dr. N.K. Sharma ji, and other colleagues. And also let us thank Dr. Amrish Kumar ji. But what is required, I think, probably in that discussion, the carbon credit, of course, whatever the answer is incomplete. The probably within a span of 1 month, it can be organized, how the mechanism of carbon credit it is happening at the either international level or at the national level. I think if you organize, I think that is wonderful. And second important also, Dr. Kannan, MRV for soil and water conservation measures. Some SOP, somebody can able to deliberate so that at least not at the different the multiple location, at least begin with the 9 location in our research centers or research forums. We can initiate that MRV protocol with respect to SWC. I think probably these are the two important the takeaway point. I think we can do it, and accordingly we can identify the resource persons to deliberate on that. With respect to the carbon credit and other thing, even some private agencies also there, NRM division of not our Asia, NRM division of Ministry of Farmer Welfare. There, Dr. Bhaskar, our earlier farmer ADG is there. I think we can contact him and we can arrange related to carbon credit. Added to that, another third topic is that how the carbon farming, any models we have at a different agroecological region that we need to discuss. I think in that also some deliberation, some discussion, it is required. Okay, wonderful for joining and for this cause of soil and also the living entity.
At
Save
present,
soil.
sir, in
Aji,
many
aji.
universities, private university, carbon credit auditor courses are running, and they are just forming a their unit or office, and for government projects they get a good hiring charges, and this is a good business and services they are providing. So in that direction also we can think how to think for the carbon credit audit, and our institute can involve in such kind of the activities.
That is true. As a consultancy mechanism, we can
Yeah.
initiate. I think that protocol, SOP, I think that we need to develop. Yeah, I note it down. Then we will deliberate. We constitute one team and we can develop protocol for that. Because we have to, our scientist colleagues also, they have to learn uh, how they are assessing and valuation part.
Right, sir. So, Dr. Ramanjit.
Yes, sir. So we are at the end of this wonderful that webinar. So we have to conclude it by the vote of thank. So first, I would like to give the big thank on the behalf of our association to our speaker, Dr. Soma Jayaraman. Sir, sir, you have given a very good speech and very informative speech, and you have ignited us to do some wonderful things in the field of soil science. And I was searching from the last 2 weeks that who will speak on this occasion. And I was searching outside, but I was not knowing that you are the gem inside this soil science field. So thank you very much, sir. And I'm very much thankful to our president also, Dr. Madhu, who is always a motivation and inspiring us to do some good thing for the association. Some we can talk science in the field of soil science and other things also. And I also I'm very much thankful to our vice president, Dr. Amrish Kumar, who is always helping hand to me and always inspiring me, and our senior colleagues, Dr. Anil Shrivastava ji, Dr. M.K. Sharma sir, and one Dr. Sharma from Jammu Kashmir, Dr. Kannan, Dr. Brijla Lakaria ji, and all. I'm thankful to all of you, and special thank to Dr. Rajiv Singh sir, who was not here due to traveling, but he has given me the name of Dr. Soma Jayaraman sir, so that we can deliver this much of a very good informative webinar. And I'm also thankful to all the regular course trainees and students and our colleagues who has spared his valuable time. And special thanks to the person who are behind the curtain, like Mangal Singh Chauhan ji and his team, Jai Kishan ji, and our association staff, Amit and Deepak. All they are working from the last 1 week. So I think if somebody I have names had left, so I'm sorry for that one. So I'm thankful to all of you. And with these words, we can conclude this wonderful webinar session. And we will put this recorded video on YouTube, and you can also watch this video. And also we will put some one-page note on our website so that the informative points can be goes to policymakers. Thank you very much, sir.